Okay, good morning ladies and gentlemen. As John has introduced me, I'm going to be talking to you about pit tagging as a monitoring in amphibian populations. So if we start off with a basic definition of what is monitoring. According to Bartle, monitoring is a regular observation and recording of activities taking place in a project or a program. So it is a process of routinely gathering information on all aspects of the project. So let's say, for instance, we want to observe a group of deer or whatever, and we would like to have individual information as well for each individual. There must be some kind of technique that must be used to help us identify individuals. So if we look at what was done in the past, even as early as between 218 and 201 BC, there were a Roman officer by the name of Quintus Fabius Pictor, and he was sent a crow by his besieged garrison, and then he tied a piece of thread around the crow's leg and sent a message back to them. And in 1803, there was an enthusiastic naturalist, John James Audubon, and he wondered whether migrating birds returned to the same site every year. So he also took a piece of string and tied it around a bird's leg before it flew south, and indeed the next year that same bird returned to the same area. And in 1899, there was the first ringing of birds for scientific purposes. This was done by a Danish school teacher by the name of Hans Mortensen, and he used aluminium rings to ring them, and even as early as 1890 he also tried the technique, but he made use of zinc rings. That poor bird, I think it was very heavy for them to carry. If we look at types of monitoring we have today, we have the VHF collars and GPS collars that are mainly used for the bigger mammals, like wild dogs and rhinos. We have bird ringing, we still use it today. Acoustic tags that are mainly for marine animals or for marine organisms. And we have head counts from helicopters. Now the head counts does not give us individual information, but it's still an aid in monitoring. If we look at techniques used for small vertebrates, they usually use toe clippings, or shell notchings for terrapins and pit tagging. But when it comes to amphibians, we have to look at what will be able to work. We can't use shell notching because frogs don't have shells, and we can look at toe clippings, pit taggings, and acoustic tags. So if we compare these techniques by the means of expenses, the advantages and disadvantages, toe clippings expense is very low. It is good for DNA purposes, but the disadvantages, it only gives us a limited individual identification system. When we look at acoustic tags, it is a very expensive technique. You get a tag that is small enough to be able to use on amphibians, but it is most suitable for 3D fish trackings. And when we look at pit tags, it is an inexpensive technique. The tag is small enough for an amphibian, and the disadvantage is you have to be at a close range to monitor the amphibian. You can't sit in a house a kilometer away wanting to monitor a specific frog. So when comparing these techniques, we decided to use pit tags. If you would agree, it would be the safest way to go. So we made use of pit tagging as a monitoring for Amnesia quackati, which is the Quackit's river frog. It is a widespread species throughout southern Africa. It occurs in natural as well as in urban areas. And in Potchefstroom, we have a large population in the Northwest University Botanical Gardens. And we decided to do a full year study on this species, focusing on its behavior. So this is a diagram of or a Google Earth image of the Botanical Garden in the yellow area, with the campus being on the left, and there's some astro hockey fields there, and astro villas there, and the train rails running past it. So before we could start any fieldwork, we had to go to the Botanical Gardens and identify all the possible sites. So this is a sketch showing the Botanical Gardens with all the possible water bodies, and we assigned a specific number to each water body. After this was done, we could actually go out and start working. I will show you these in the following slides, how we did those. And after all that was done, we could mark the individuals with a pit tag. So before we went out on fieldwork, we made sure our flashlights were charged and our team spirits were turbocharged. And we could go out and we searched for frogs with the aid of our flashlights. And we saw them, we caught them swiftly because they are very good jumpers, these species. We put them in plastic bags, we weighed them, each individual, we measured their snout to vent length, and we determined their sex. So each individual had an information sheet where we filled in all their info. And after this, we could insert the pit tag subcutaneously, and we just covered the incision hole with a little drop of super glue to prevent infections. And then in the following fieldwork evenings, we could go out with our handheld scanner and we can search for frogs, scan the frog, and then we have a unique barcode for each individual showing us their identity number. So fieldwork took place every 14 days. It started off with a short night fieldwork where we would go out into the garden, search all the sites for frogs, and then the following evening we went back. It was a long night fieldwork. Donovan would agree with me. It was long hours. We started from 7 in the evening to 3:30 the next morning at one specific site where we would search for frogs every 90 minutes. And to make this easier for us, we made sure we divided this site into a 1 by 1 meter grids, and we made sure we marked all the frogs at that site. So even when during June or whatever we found a new frog, we would mark it to make sure if we found it later, we will know which frog it is. And because we did this for this site, it was easier for us to note the frog's exact position in the pond and just all extra information about the frog and overall behavior. So the site we used for this long night fieldwork was pond 6 in the garden. This is just an example of the grid overlay we put in over the pond. So this is the water body in the middle. We had a wooden deck with an oriental ornamental pond there. We had some vegetation around the ponds and some trees and a rock footpath, and the inflow was that side and outflow was that side. So it was a very nice pond for a nice population of frogs. So you will understand now why we chose pond 6 for our long night fieldwork. So the following results is just to give you an example of the types of results we got from this project. So we could look at movement between the ponds when it came to the short night data. So we looked where the males, females, and juveniles moved between ponds. And as these arrows indicate, we can see that indeed all 3 of them moved between ponds, all 3 types of the frogs. And we could see that the movement was either between big ponds or it was either from a small pond to a big pond. And that is why we decided to use pond 6, because there was a lot of frogs moving towards pond 6. So we decided this is the hot spot, this is the pond to be at, so that's why we used pond 6 for the long night fieldwork. This is a graph showing the male-female numbers throughout the entire year in the garden. The male numbers reached the plateau during the end of summer and the beginning of autumn, and they declined a bit during June, but reached a maximum during September, which is this species breeding season. While the females had a maximum during March. Their numbers had a maximum during March and only declined after that, and just slightly increased again in September. So because we had individual numbers for each frog, it was easy for us to look at movement within pond 6 in different ways. We could either look at movement within an evening, what movement took place in a pond. We could look at individual movement in site 6 and through the entire year, how they moved around. And we also could look at their distribution within seasons around this pond. So this is a typical movement within pond 6 during a summer's evening. The red dots indicating the females present, and the blue dots indicating the males present. So there was only 3 males, and they were quite stationary. They didn't move around that night, but the females were a bit more active. But when we compared this with a typical evening in the winter, there's only 1 female left. If you can remember the graph I showed you guys with the females having low numbers during the winter months, and there were a lot of males, and they were a lot more active than in the summer. And this is an individual movement for a specific frog, this frog. It was a young male. And the B indicating the quadrant we first marked this frog, before we first found it and we pit tagged it. And the E indicating the quadrant we last saw it when the study was terminated. So this frog was moving around quite a bit through the entire year. And then also, every time we saw extra behavior for, let's say, a male is calling, we would note it, and that went into the database. After sorting the data, we could see which males were calling and which males had preferred calling sites. All of these males had their preferred calling sites throughout the entire year. So each time they were noted calling, they were sitting in those areas. So our conclusion that we can thus make from this study is that pit tags is a great monitoring tool for amphibian populations. It is a very cost-effective technique. The tagging process is simple and it's not labor-intensive at all. And it does not hinder the frog's movement, so nothing happens to the frog. Thank you.